I just want to do a bit of a run through just on some of the basic area shapes. Okay, so the first one, we just look at the square. So when you're looking at area, you're actually looking at square units. And to measure area, you're looking at how many square units fit inside a shape. So a square unit, like say for example, is 1 centimeter by 1 centimeter, or you could have like 1 millimeter by 1 millimeter. 1 centimeter by 1 centimeter is equal to 1 centimeter square, or 1 square centimeter. You could also have like a bigger shape. If you think about what a meter is about from one side of your shoulder. Like if you get a body part and you look at what a meter is, me it's my shoulder on the right hand side to the tip of my finger on the left. So like if this was me, there's my shoulder, so to be from about there, I've measured this, and that's my 1 meter. So it would be 1 meter by 1 meter. And 1 meter by 1 meter, we call that 1 meter square. So if we were measuring the area of a square, and it was like we're looking at centimeters, it would be how many square centimeters there are. So if each of these is 1 square centimeter, then it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9 square centimeters. But we soon figure out, rather than counting the number of squares, if we look how many squares are on this side and how many squares are on the other side, and you just simply, if you look at a relationship there, if you multiply them together, see if you think about that too, you would have 3 rows of 3. So if you did 3 rows of 3, that would equal 9, and that would give you 9 square centimeters. So for a square, as a rule, if you just do side times side, and if you use a symbol like S for the side, then to find the area of this square, the area of a square is side times side. You can simplify that to S squared. So this enables you then to find the area of a square very quickly. So if this was, say, 5 meters, you could apply the same theory. That would be 5 times 5, which is 25 meters square. Okay, if you needed to work backwards, first of all, you could find the area of the square. So if you wanted to find the area of each of these squares, so let's just say that was 7 centimeters, and it would be 7 times 7, which is 49 centimeters square. But if you're given the area of a square, then you just got to work backwards. So given the area of a square is 64 meters squared, find the side length and maybe find the perimeter. Then all that you would need to do is you just work backwards, because we know that side times side will equal the 64. So what times what gives you 64? Now you could just think what times what and know your times tables, or you could apply the theory of equations, and the opposite to a square is a square root. So if I square root 64, I'll just get 8, and that would be 8 meters. And then if you wanted the perimeter is the distance around the outside. So if each of those was 8, the perimeter would be 8 plus 8 plus 8 plus 8, which is 32 meters. The second shape I just want to look at is your rectangle, and in the same manner, like if we want to get how many square units actually fit inside that shape, we just need to go, how many square units along one side and how many square units along the other side. And that's a really quick way of finding how many square units altogether. Because in each of these rows there's 1, 2, 3, 4, 5, so there's 5 centimeters, but there are 3 rows of 5. So the area of the rectangle would be 3 lots of the 5, which is 15 square centimeters, which makes it easier than just counting up the 3 rows of 5. Okay, so the area of the rectangle would just be the base times the height. So we call this the base, we call this the height. So the area of the rectangle would be 5 times 3, which is 15 square centimeters. So if this was 9, say, millimeters and 3 millimeters, and it's a rectangle, Then to find the area, you just go 3 9s, 27, so it would be millimetres square. Now, if you wanted to work backwards, like let's just say this was 60 metres and that was x metres, and the area is equal to 64 metres, find the x. Just do the whole rectangle. Then that would be 16 times x equals 64. And when we work backwards, if you divide by 16 on both sides, you end up with x equals 4 metres. Okay, now I just want to have a look at one, say, maybe that has 4p and 2p. And we're just going to say that the area is equal to 128 metres squared. Find p. Okay, so if you're going to find p there, this is just with algebra, an expression for the area would be 4p times 2p, which would give you 8p squared. So you can then say, therefore, 8p squared equals 128. And to get p by itself, first of all, divide by the 8. So you go p squared equals 128 divided by 8. You end up with 16. So this would be like what times what gives you 16. And it would be 4 times 4 is 16. So p would be 4. Or you could simply just apply equations rules, and the opposite to the square that is sitting there, that square, is the square root. And that would be another way. You could go square root of 16, so p would be 4. And you just apply your equation techniques, enabling you to do that. Okay, the third shape I just want to take a look at is your triangle. Okay, now with the triangle, basically, if you have a look at this, we're going to look at 3 different types. Okay, I just want to have a look at 3 different things. And I'm going to actually, there is a practical on this that I'd like you to do as well, just to figure out how you would find like the actual area. Okay, now if you look at this, we'll call this base times height, because that's the base and the height of the rectangle. And if you could try this yourself, like just get a piece of paper and just mark 1 point on the top there, and then if you draw up your triangle just by drawing a line back to each corner. So draw the triangle up just by drawing it back to each corner. And what we're interested in here is actually finding the area of each of these. Now, we're just going to have a look at this. If that was 6 metres and that was, I might make it something smaller so it looks like it's more to scale. That was 4 metres. Then the area of the rectangle would be 4 times 6, which is 24 metres squared. Now, what I want you to think about this, if you get your piece of paper and just mark on your piece of paper, just a point there, and draw your triangle back. If you get this rectangle that is sitting here, that one, and you cut along this line, that you cut it out, and then you get this one and you cut it out, I want you then to play around with it. I want to see if you can put this rectangle and see if it'll fit exactly. If I cut that in half, will it fit exactly in there? And then get this rectangle and fit it exactly in there. Okay, and to me they look like exactly the same area, don't they? So if you think about what the area of the triangle would be, the area of that triangle, because these are exactly the same, would be half times the area of the rectangle. So it's going to be half times 24, which is 12 metres squared. Okay, so if you think about that for this formula here, the same thing. If you cut out this side here and you put it on top of there, you turn it around and put it on top of there, then the area of the triangle will be half times the area of the rectangle. Now the area of the rectangle is just base times height. So that then gives us the formula for the area of a triangle, which is a half the base times the height. Same thing here, you put this in half, cut this one out, flip it around and put it there, cut this one out, flip it around and put it there, and it gives you exactly the same formula. So the area of a triangle is a half base times the height, okay, which is half that of the rectangle. So if you wanted to find the area of, say, this triangle here, and that was 6 meters and 12 meters, then the area would be a half times 12 times 6. And you can just put that in your calculator. If you were doing it in your head, you can do it in any order you want, because the order that you multiply is not going to matter. So you go half of 12 is 6. 6 times 6 is 36. You could do the 12 and the 6. 12 and the 6 is 72. Half of that is 36. Okay, because when you're doing that, you're effectively just getting like the area of the rectangle, and then you are halving it. All right, now I'd also like to chuck in there just a couple of different types of triangles. So the right angle triangle, that one's just set up really nicely for you. I want you to realize that when you're looking at this, you need the height and you need the base. So you need height and base. It has to be multiplying the perpendicular height by the base. So the area of this is a half times 9 times 5, a half times 45, because that's the area of the rectangle, and that would be 22 and a half, and it would be meters squared. Okay, so make sure that when you are doing the area, you are doing the base and the height. So let's say that was 5, and this was 4, and this was, say, 10 meters. All right, so when we're looking at finding this area, I just want you to realize that this 5 is really useless, because this 5 is not the perpendicular height. You always need to make sure you've got the perpendicular height, because when we originally derived it, it is based on the perpendicular height. So it's a half 10 times 4. 10 times 4 is 40, so it's a half of 40, and a half of 40 is 20 meters squared. Okay, so what I want to just show you for this one here is that the base of this triangle is actually the 3 and the height is the 5. So if we're going to use the formula, the area would actually be a half times 3 times 5. 3 5s are 15, and a half of 15 is 7.5 centimeters squared. Now, I know it seems funny because you've only got part of the base there, but we actually only have part of the triangle. So I just want you to think about, like, if you look at the whole big picture, if you did the whole big triangle there, let's see if we get exactly the same thing. So if we went a half times, now that's 7 times 5, that'd be a half times 35. So that would be 17.5 centimeters squared. That will give you the whole big triangle. And then what I'm going to do is I'm going to take this smaller triangle here and I'm going to take it away. So if we look at that one there, and when I do that, if I do the big triangle, take away the small one, I should have the desired triangle. So I go a half times 4 times 5, which is 17.5 minus a half times 20. 17.5, a half of 20 is 10. 17.5 minus 10 is 17.5. So it is much easier just to realize that this is the base and this is the height. And then you just go a half base times height. Do you notice the height is perpendicular to the ground? Okay, because, you know, if you were measuring someone's height, they have to be perpendicular to the ground. And the same as these triangles, the height will be directly vertically up, and the height is always perpendicular to the base. And there's your base. Your base is 3. So that's why it's going to be a half base times height. So I'm just going to do a triangle question. We'll do one like that. If that was 8 meters and 2 meters, then the area of that, that's right angle, the area of this shape here would equal 1/2 times 2 times 8. We don't even need to know what this little bit here is, because we know that this will definitely, if we use this as the base and this is the perpendicular height, it will give us that area, because it's the same as doing the big triangle minus the little one. So 1/2 of 16 and 1/2 of 16 is 8, so it ends up being 8 meters square. And finally, I just want to give you another, like a working backwards, because I think it's a good habit to get into. If the area of a triangle, say, was 12 meters squared, and the height was 3 meters squared, find the base. Okay, so we have a triangle, we have the height is 3, the base, and we go 1/2 times 3 times the base will equal 12. So 3 times the base. Now, when you look at this with fraction work, that's going to be 3b on the top, and 2 times 1 is 2 equals 12. Now, to actually solve that equation, you times 2 on both sides. 3b equals 24. And then to get rid of the 3, you divide by 3. 24 divided by 3 is 8. Okay, and you end up with 8 meters.